So let's learn how to solve for the value of x in this nice exponential problem. X to the power of 64 equal to 4 to the power of x. If you are new here, don't forget to give this video a thumbs up, share it with friends and colleagues, and remember to subscribe to my channel for more simplified mathematics content. Now check this out. If you are asked to solve this question, what will come into your mind first, or what will you desire doing first? My main aim will be to reduce the powers, especially the power of 64. So how do we do that? If I multiply both sides by the power of 1 divided by 64, I can be able to do away with 64. Now let's look at that. I have the value of x to the power of 64. If I multiply it by 1 divided by 64, and whatever I do to the left hand side, I also do to the right hand side. So I have 4 to the power of x all to the power of 1 divided by 64. Great. Now in the next step, I will see how to reduce this problem. And to do that, all I need to do is to see that 64 clears 64, and then on that side I'll be left with x, and my x will be equal to 4 to the power of x divided by 64. Great. So what do I do next? I'll have to think of removing x from the other side, and to remove x from the other side, I have to multiply both sides by the power of 1 divided by x. So I'm going to have this to become x to the power of 1 divided by x. What I do to the other side, I also do to this side, and that will give me 4 to the power of x divided by 64 all to the power of 1 divided by x. That way I can be able to clear x, and that is going to give me x clearing x. And what will that expression give us? The expression will now give me the value of my x to the power of 1 divided by x equal to 4 to the power of 1 divided by 64. Great. So what do we do in the next step? The next step, I'm going to see how I will make it in such a way that we'll have same base and same power in the expression. So how do I do that? To accomplish that, I'm going to put in an assumption. If I have x to the power of, if I have x to the power of 1 divided by x, right, I can say this is equal to 4 to the power of 1 divided by 64. Let's say multiply by 2 divided by 2. I have not changed anything because 2 divided by 2 is still equal to 1. So that will still give me the power of 65. So the 64. Now the next thing I need to do from here is to reduce this expression. From this expression now, I can have my x to the power of 1 divided by x to be equal to 4 to the power of 2 divided by 64 times 2 is 128, right? So I can reduce that expression. If I reduce that expression, I'm going to have that expression to now give me x to the power of 1 divided by x equal to, this is going to give me 4 to the power of 2, right? And that will be all to the power of 1 divided by 128. So if I expand that, I'm going to have this to become x to the power of 1 divided by x equal to 4 to the power of 2 is going to give me 16 to the power of 1 divided by 1, 2, 8. Now I'm going to simplify further. If I simplify further, let's say I'm still multiply here by 2 divided by 2. I've not changed anything, and that expression will now give me the value of my x to the power of 1 divided by x equal to, this will give me 16 to the power of 2 divided by 128 multiplied by 2 is going to give me 2,556. So I have that to become 256, right? 2 times 2 is 4. 4 plus 1 is 5. Then 2 times 1 is 2. Good. So that expression is now going to give me x to the power of 1 divided by x equal to 16 to the power of 2, and all multiplied by 1 divided by 2, 5, 6. Great. Now from this point, I'm going to also find out that 16 square is going to give me an expression. So this is going to give me x to the power of 1 divided by x equal to 16 times 16 is going to give me 2, 5, 6, right? And that will be to the power of 1 divided by 2, 5, 6. Now, do you notice something? The base is equal to x, and 1 divided by x is also equal to something similar to the other side. So what do I do? If I equate the exponent, I'm going to still have my x to be equal to 2, 5, 6. And if I equate the base, I'll have my x to be 2, 5, 6. So the value of our x will be equal to 2, 5, 6. And that appears to be the solution to that question given to us above here. Great. Now I want us to check to find out if our solution is actually right. The original expression given to us is x to the power of 64 equal to x to the power of 6. So is those two expressions equal? If I take this to become x to the power of 64 equal to 4 to the power of x. Now replacing x to 256, I'm going to have that expression to now give me 256 to the power of 64. Is it by any way same thing with 4 to the power of 256? Let's find out. So if we simplify that expression using the laws of indices, you come to see that 2, 5, 6 can be reduced further. If we have 4 to the power of 4, 4 to the power of 4 can give us 2, 5, 6. So we'll have 4 to the power of 4, right? All multiplied by 64. While on this other side, if we use exponential value, we are going to look at that to be 4 to the power of 2, 5, 6. Now, the reason why I did that is because I have a base here 4, and I need to express this such that I'll have a base of 4. 4 times 4 is 16, then 16 times 4 will give us the value 64, and then 64 times 4 is going to give us 2, 5, 6. So if we look at that expression, we'll find out that it's same. 4 times 65 is going to give us 2, 5, 6. So we'll have 4 to the power of 2, 5, 6 equal to 4 to the power of 2, 5, 6. Voila. So that tells us that the value of our x equal to 2, 5, 6 is actually the value of x that satisfies that exponential equation that is given to us up there. You see, it's very easy doing this. I know you did enjoy solving this math question with me. Don't forget to give it a thumbs up, share it with friends and colleagues, and remember to subscribe to my channel for more simplified math content. Thanks so much for watching, and bye bye for now.